Hey YouTube, welcome back. Osmocom-BB tutorial, part 4. GSMTK actually working. Yes, you heard that correctly. With some help from a cybersecurity professional called Marcos from Brazil, we have gotten GSMTK working for you guys. I think you guys are going to love this video. We've got a lot to cover, so we'll keep the intros very, very short and we'll proceed with the video. So it's been a while since I've done some GSM content. I know you guys love a bit of GSM and 2G. If you haven't watched this playlist, go and watch that if you don't know what I'm going to be covering in this video. But for those that did watch it, you'll see in part 3 that we sort of hit a roadblock when we were trying to run GSMTK. Well, we've solved that problem now. So, yeah, let's get stuck into it, shall we? So I tried to start from scratch and compile GSMTK for you guys and show you guys how to do that, but I spent a few hours on it and I just couldn't remember how I got it compiled. So I'll re-upload the GSMTK zip file, and I think this is a good point to mention that you'll actually need Dragon OS LTS, which is based on Lubuntu 18.04. And for the simple fact is GSMTK is quite an old toolkit and it won't run. I could never get it running on newer versions of Dragon OS. So I'm using Dragon OS LTS final ISO. And also I guess I should mention that you actually need a working Kraken hard drive and also Kraken compiled and working on your computer. So yeah, I'll just proceed to open the GSMTK zip folder. Just remember, guys, in Dragon OS LTS, if you drag stuff across, if you guys drag stuff across this here, this area here, you're going to have a bad time. Dragon OS will have an absolute meltdown. So I'm just going to drag this over here and just make sure I can't drag any files across that little favorites bar in the side panel there. So that extracted fine. We've got some setting up of our environment, some configuration, some file copying to do. So hopefully you guys can see this. I've got all the commands and stuff we need to do written in this text document here. So we're just simply going to copy and paste these commands. Oh, I've already done that. That's in that terminal window at the top there. So I'm just going to copy that. And that's copying a hidden folder with some configuration files that GSMTK needs to perform its duties. We need to, so the configuration files are already edited, but I'll show you guys how to actually edit, what you guys need to do to edit one of these files here that we just copied. So we'll paste that command to open the config file inside the .omgsm hidden folder. I'll hit enter on that. Move this over here so you guys can see. So you'll see here, there's 3 paths here. You guys will have to edit this part here. So my Linux usernames are always just username. Whatever your username is in Linux, you guys have to substitute where it says username for yours. So if you guys don't know what your username is, it's whatever this word is, or letters or symbols or numbers before the @ symbol in the host name of your Linux PC. So mine's showing username and we've got username there already, so I'm not going to touch it. If you're setting up GSMTK from scratch, guys, the default configuration file has the wrong port for Kraken. So Kraken will be running on quadruple 6. So just make sure you guys have that configured. And it's very important, you need to leave these forward slashes at the end of the paths, okay? And there's 3 of them, so make sure you modify 3 of those paths for your environment. I'll just save that file, which I've already done, and then I'll close that. That's all good. So we need to make the executables from GSMTK findable across our entire system, right? So what we're going to do is we're going to edit our .bashrc file, with leafpad once again. I'll move this over here so you guys can see what's going on. We scroll right down to the bottom. And we're going to export this path. And what this is doing is basically every time we start a terminal window, Linux is going to know where to find a couple of the binaries and bash scripts used by GSMTK. So I'm just going to save that file now. We close that. So normally when you add stuff to your .bashrc file, we need to restart the terminal window. But I'm not going to do that because we need to install SQLite. So I'll proceed and do that. And the reason SQLite will write a few files to the bashrc file as well. So we'll just install SQLite first, and then we'll quit our terminal window and then restart it. There's a couple of prompts, and we can just use the default prompts when we're installing SQLite. So I've tried to record this video so many times, guys, and it's been very stressful trying to get this to work all in one go. So I'm very confident. I've done it 3 times today, rehearsed this video, so hopefully it's going to work. Yeah, we just use the default options. Yes. I'll be very happy to get Osmocom-BB tutorial series out of the way. No beer today, guys. I've got to cook dinner for my mother tonight, so no afternoon beers for me. So I can bring my A-game, cooking game. So this will take a little while too. So yeah, for newcomers to the channel, Osmocom-BB is a very, very cool tool set where we actually repurpose old 2G phones from the early 2000s, or maybe late 2000s, sorry, and turn them into GSM. I don't want to say the S word, but we can use them for GSM security research, we'll say. I was going to say sniffer, but YouTube doesn't like the word sniffer when it comes to cybersecurity stuff. All right, cool. That finished successfully. Okay, this is the point now where we will restart the terminal window now. We only need to restart this one because all the other windows I've got down here don't require to know where the binaries are for GSMTK. So, all right, so this needs a little bit of explanation. So I'm using Deka for this. Deka uses, when it does the search like the lookups in the rainbow tables for Kraken, it displays the found match in the rainbow tables as base 10, I think. No, base 16, sorry, but Kraken expects base 10. So what the find KC binary does. So there's a patch binary that comes with GSMTK. So what I'm going to do is just check which find KC binary we're using, because I'm using Deka, right? It's already found the one that's inside the GSMTK files in the bin folder here. That one is patched, so I believe it can process base 16 and base 10. So if you guys don't know what base 16, base 10 is, base 10 is decimal. That's just your normal numbers, like counting to 10 when we're kids. And hexadecimal is base 16. For you guys, I'd probably just run this command here, and then you can have the patch binary in your user local bin directory. So I'm just going to run that command just because, and you guys should probably do that as well. All right, so we need to do some firewall routing, basically, because how GSMTK forwards packets to Wireshark or Tshark is a bit different to GRGSM. So there needs to be we need to use IP tables to perform that routing in the firewall for us. So I'm just going to run that command. So this is the point now, guys, where you will run Kraken now. Fundamental difference is GSMTK requires Kraken to be listening on a telnet server with a port of quadruple 6. Obviously I'm not using Kraken, but if you guys were to use Kraken, this is the command that you guys would run. I don't want to run this and test it because then it might tie up port quadruple 6 on my computer, and then I have to restart my computer and all that. So we're not going to touch that. But yeah, you guys will run that command there to make sure Kraken's listening on telnet server for GSMTK to send it the Kraken command. So yeah, here's my couple of windows here for Deka. I do have a Deka tutorial series coming, guys. I've simplified it, the process, to get that working for you guys, and I'm sure that you're going to love it. I've had a lot of people email me about Deka. So if you guys don't know what Deka is quickly, it's Kraken, but it runs on GPU. So instead of using slow multi-purpose CPUs like what are embedded in our computers, you can use GPU cores, and yeah, GPUs have like thousands of cores as opposed to maybe your computer has 8 or 16 cores in the CPU. So yeah, that's the difference there. Okay, so we're ready to actually start setting up our GSMTK environment now. So there's a couple of commands we need to run. This is very important. Don't change the name. Like if you're following my tutorial and you've used my config file, don't change this, okay? Just leave it as TK test, please. So we can see here that's created a folder called TK test. We need to cd into that directory. We need to run this bash script here, and then if you keep an eye on the TK test folder here in my file browser, you'll see a bunch of files and folders get created, so that's good. Now, this is the point where we need to add the burst file. So if you got, like what I said before, guys, Osmocom-BB, the burst IND branch can actually capture GSM data and write it to some files with a .dat extension. Yeah, go and see this part 2 of this tutorial if you want to know more about the burst IND branch of Osmocom-BB. So I've got a couple of files here, not many. I've only got 2 files here, but they're quite large and they've got lots of frames there that GSMTK can have a crack at attacking. So I'll go into the TK test folder. We'll go to new. So I'll just highlight my 2 burst files. I'm going to dump them in the new folder there. And I'll just return to the TK test directory now. And now we need to run this command here, and that's going to add those burst files to the database, GSMTK's internal database. So I'll just hit enter on that. Oops, sorry, we need to cd TK test. How about we try that again? There we go, and you'll just get this INS. I guess that stands for insert. I don't know. Now we need to generate some statistics now. So GSMTK, it uses a database. It generates statistics. They call it a statistical guesser or something like that. So we just need to paste that command there, and I'll hit enter on that. We should see some files showing up. We get some stats here. We've got some stats downlink files. We've got some SDCCH downlink files, no uplink, and we've got 74 raw frames. So hopefully when we initiate the cracking process, it won't take too long, as opposed to having like tens of thousands of frames. So all right, so this is the big one, guys. We run this Python script here called TK napalm X, and I'm going to paste that there, and then I'll minimize my text document there, and then so we can see Deka doing its thing. Cool, that's working. So yeah, while it's doing that, I guess I'll just explain here. So I wanted to use my GTX 1080 Ti for this. Unfortunately, I've tried for days and days and days. I could not get Dragon Ice LTS booting on my GTX 1080 Ti computer, but it boots fine on my GTX 1030 computer. I've got no idea why. NVIDIA is the bane of a lot of people's existence, Linux users in particular. Yeah, that's just how it is. So this is going to take a little while. Yeah, I guess I don't know. I think the GTX 1030 has maybe like 1500 CUDA cores or something, and my GTX 1080 Ti has 3,500, I think. So it's roughly about half as slow as the GTX 1080 Ti, but that's all right. Doesn't matter. So while this is happening, oh, there we go. So keep a lookout for these green. I'm colorblind, so I can't actually really tell the difference between these two colors here, but I guess you guys can. I think it's green anyway. We get these messages here saying cracked bursts. And if we go to the cracked folder, we can actually see that GSMTK has copied that file to the cracked directory. So that means it's successful. So yeah, keep an eye out for the green cracked messages, and they're your success messages essentially. So, and yeah, you can just, this window will just infinitely scroll for a while. You'll see very quickly that the GTX 1030 can crack heaps, many bursts, actually quite quickly compared to CPUs. I was surprised about how quick it was. So, this is going to take a little while, guys. I guess I'll take this opportunity to give disclaimers now. So, I'm not a hacker, guys, okay? I know there's a big common misconception going around that I'm like some black hat bad guy, threat actor or something, I think you call it in the cybersecurity thing. I'm not. I'm a RF and SDR enthusiast. I just like radio and RF stuff. I never want to deploy these tools against a real operating GSM network, okay? And you guys shouldn't either. And if you guys choose to do it, you will be going against my wishes, because I don't want anybody to replicate what I'm doing in this video and deploy it against real 2G networks and intercepting data. That's naughty. Don't do that. And if you get yourself in trouble doing this kind of stuff, I've got no sympathy for you, I'm afraid. And yeah, basically this video is just being made for educational and experimentation purposes only. And yeah, I guess I'll turn my microphone off and I'll turn the camera off, and then I'll come back when this is done. I'll speed the video up, and yeah, see you shortly, guys. Okay, guys, I'm back. So that actually didn't take too long. Yeah, very achievable with even a modest graphics card like what I'm running. So in a nutshell, basically what GSMTK is doing, it's built this database of, like GSM frames and packets and all that, and then it's using statistics and stuff like that to start guessing which encrypted frame it can XOR with a encrypted frame, and so it's doing the plain text guessing and stuff like that, and then once it gets some bursts to start cracking, it actually sends it to Kraken or Deka via Telnet quadruple 6 port. And then yeah, you can basically see, yeah, Deka was doing all the lookups and all that. And yeah, we've actually successfully cracked both of those files. So that's excellent. And so if we go back to our TK test folder, you'll see that there's a SQL database called keys.db. This is the file that all the A51 session keys are stored, we'll say. This will just keep running too. I don't know what, that'll just keep scrolling, but everything's finished now, so it's probably safe to quit that now. Quit that bash script. Oh, sorry, it's a Python script, TK napalm X. So what we'll do is we'll use SQLite browser to actually open that keys.db file. Might be really small. I was actually supposed to change the font size. So if you guys don't know, NVIDIA drivers essentially trash your Linux installation, and all the scaling's wrong and font sizes are wrong, and it's very painful. So we'll just change that to 22 so you guys can see. And there we have it. I'm actually going to blur that out for you guys, so I can't move that window around. But yeah, those are the A51 session keys, we'll call them. And that was found using the Deka looking up the rainbow tables. So yeah, that's really, really cool. I'm very happy that we got this working. Okay, so what can we do with that data that we just cracked, essentially? Well, we can run tshark in a second terminal window. And then finally, we can use this bash script here, which is part of GSMTK. And then if I run that, that is going to, I dare say, look up the keys in this database and then match which frames, I guess, were secured with that with the found key, and then it's going to replay that data in tshark for us. So I'll hit enter on this command, and there we have it. I'm probably going to have to blur this data out because this is actually real GSM data from a real 2G network, so I really do not want to display that for the entire world to see. But yeah, we've got some data there. Yeah, so anyway, that's it. We've reached the end, guys. That's the Osmocom-BB tutorial series done and dusted. So yeah, I hope you guys enjoyed that. Sorry for the year-plus delay, but I sort of hit a roadblock getting GSMTK to work, and then that's it. I just sort of quit doing GSM stuff. So yeah, in preparation for this video, it was really, really fun getting back into the GSM decoding tools and that. So yeah, I hope you guys enjoyed the video. I'll catch you all later. Bye.